that tied into the stuff that I was doing, and so I think this is your first meet. This is the first time participating in the OpenSSF meetings, right?
It is.
Yeah, welcome.
Hey, welcome, Jonathan. You want to tell us a bit about yourself?
Sure. Yeah, I'm right now. I've found myself as a co-founder of a company dealing with automated source code refactoring, style preserving, type aware sort of stuff. So it's kind of right up this alley. It's we used to do like framework migrations and vulnerability patches, dependency changes, and so forth. I worked with Jonathan a bit last year on one of these that he'll demonstrate a little later.
Yep.
Do you mind putting a link in the chat? I would love to just go poke around and see what you're doing.
Absolutely, will do.
Like, no, I'm not going to let you inform yourself. Before we get into Jonathan's presentation, anybody have any opens?
No big open, but just those of you, there was an OpenSSF town hall yesterday, and I think it went well. And the metrics, the security threats folks have some interesting metrics things. So there we go.
All right, shall I?
Go for it.
Peachy.
Only delayed 2 weeks.
Yeah, well, it's okay. All right, any window. Okay. So, all right. So I gave this talk previously at a conference called GitHub Nova, which was a private GitHub Stars only event. So, but the title of this talk is called "Creating Thousands of Pull Requests to Fix Open Source Security Vulnerabilities at Scale." Hi. My name is Jonathan Leitschuh. I'm a software security engineer and security researcher. I'm currently at Gradle. Why do I do this sort of thing? I have ADHD. I dig into holes and I go my focus can get and I get carried away with security vulnerabilities and that's how I find things. This is a tale of two widespread security vulnerabilities. We're going to start with the first one, which is a JVM ecosystem vulnerability, which is the use of HTTP to download your dependencies, either in Maven POM files or Gradle build files. But this, the Java ecosystem before 2020, the January 1st, 2020, a huge number of projects were using HTTP to resolve their dependencies. The other vulnerability was a vulnerability to code generator called JHipster. Where there were 15,000 repositories across GitHub with this generated code in it that had this vulnerability. And I found the vulnerability in the code generator, got the code generator fixed, but there were still all these generated projects that were vulnerable. So let's start with the JVM ecosystem use of HTTP. This is a classic man-in-the-middle attack of your supply chain components. Two major build tools, Java for the Java ecosystem are Maven and Gradle. Neither of them do any sort of artifact verification by default. So basically the only verification that you have that you're actually resolving the component that you asked for is TLS, right? Like, guarantee that nobody's monkeying with your connection between the server and you. Unfortunately, I found that there were a wide number of repositories all over the ecosystem that were not using HTTPS. Back in 2014, just after the Snowden revelations, Max Wietzman wrote up an article called How to Take Over the Computer of Any Java, Scala, or Groovy Developer that kind of called out Sonatype, which is the biggest artifact host in the Java ecosystem for only offering HTTPS if you paid a donation fee. And so he published that article and called them out and said, hey, you're basically leaving this insecure for everybody. And he wrote Dilettante, I think is the product, that was basically a thing that backdoored jars files. And so this is his demo of, downloading a jar file, backdooring it while it was in flight, and then dropping in this swing component that popped up saying you didn't serve your jars with SSL. Of course, cats. So I, in 2019 I found this bit of code in my repository. And I'm like, where did this bit of code come from? And what I found is I'd actually copied this code from one of my dependencies, their source code. I'm like, huh, okay. So I reported it to them. And then I'm like, I wonder where else this is. And then I started looking, and it just kept growing as this problem. Like, I just found it in more and more repositories across GitHub. So let's look at some quick examples of where this vulnerability can exist. In Gradle files, you can have it in your build script. Can you see my mouse?
Yeah, I can see it.
Okay.
Yes.
So you can have it in your build script block. This scope is dependencies that get resolved into the Gradle build, which is like the thing. These are like plugins for Gradle to change Gradle. This is your repositories block for actually dependencies to your compiler, and are loaded on the class path for tests. So this is not the build, but this is just like the application that you're building that you're going to produce, either your like Android application or your WAR or whatever. And then this is where you have uploading of artifacts, right? So this is like I'm publishing a library and I'm publishing over HTTP. And in this case, you're also leaking credentials because you're uploading it with credentials in plain text. So these are the three main places you'd find it in Gradle. In Maven, you have the repositories block. And this is, you know, dependencies of like where, again, the compiler and loaded on the class paths for tests. This is distribution management, which is used for publishing dependencies, also has credentials. And this is plugin repositories. This gets loaded into these are dependencies that get downloaded and run in Maven as plugins.
Jonathan?
Yes.
Yeah, you mentioned the password. I mean, not only are they getting set in the clear, but they're being checked in and stored in repos, aren't they?
No, those are usually in
No?
settings files. But usually, so if you're reading these things in,
Okay.
for here, usually the repo username and repo password, those are usually read in from environment variables or properties, something like that. I mean, it's not to say that people don't just drop code in there, but most often it's fed in from one of those external sources.
Okay, good.
So who's vulnerable? The JetBrains, the Eclipse Foundation, Gradle, Red Hat, Kotlin, Jet Spring, you know, all these projects. Oracle, the National Security Agency, LinkedIn, Stripe, all of these projects had this vulnerability in their open source projects. I made a bit of bug bounty money from a couple of these companies. A lot of them didn't pay me a thing, and it was a large project. So I reached out to Sonatype, which is the biggest house in the Maven ecosystem, and said, hey, this is a vulnerability I'm finding everywhere. What's going on? And they reported back after a month of looking at their data that 25% of the Sonatype Maven Central downloads were still using HTTP as of April 2019. And I'm like, great, let's fix this. So I pushed forward a proposal. How can we fix this? So I pushed forward a proposal on or around January 15th, 2020. I contacted all these artifact servers and said, hey, let's fix this together. Let's shut off the use of HTTP, like not a redirect, but like full stop. Like you will get a 500 or whatever, right? Like you won't get a 302 or 301 redirect. Like it just, doesn't work. And all of these different artifact servers that are the biggest ones in the supply chain for the Java ecosystem all just full carte blanche said no, stopping requests that support HTTP. And this actually worked. I saw some like very confused Stack Overflow posts on the day that things shut down, but yeah. Yes, broken software everywhere. So what about everybody else? So these are the biggest, right? These are the biggest artifact servers, right? Maven Central, JCenter, Spring, right? But there are other people that are relying upon artifact servers that are like, my company, or Jenkins has their own artifact server. There's like a bunch of different companies that or Eclipse Foundation, right? Eclipse Foundation, I couldn't get to drop HTTP support. They still haven't dropped HTTP support. They do a redirect now, which is whatever. So enter CodeQL. So GitHub bought SEML, which is now CodeQL. And when I saw it, I'm like, I previously been doing this research with like GitHub fuzzy searches. Huge pain in the keister. Like GitHub search functionality, not all that good. It's good enough for finding specific things if you know the right query, but like it's very fuzzy. And it also only returns the first 1,000 results. And it's really hard to do anyways. So when GitHub bought SEML, I was like, okay, I can use this. So I wrote this CodeQL query, which looks for, I can't do Gradle, but I can do Maven, because when CodeQL runs, it slurps up the code and also XML files. And I can write this CodeQL query that finds these dependencies, or finds this repositories block and sees that you're using HTTP or FTP in that block and flags it for you. And for this query, they sent me they paid me $2,300 bounty for writing this query, as well as some associated documentation. And now, if you go to lgtm.com and look for HTTPS or SFTP URL, the failure to use this, if you look for this query, you can just see pages and pages and pages of this vulnerability in open source software across GitHub. But this still left thousands of projects vulnerable. So we've gotten shut it off at the source, fix it, or detect it, but how do we actually fix this? So I said, okay, like I've done, you know, I've written this CodeQL query. Let's use it to like actually fix all these vulnerabilities. Right, like they're open source, kill them in fire. So what is what are we looking to do, right? It's a simple diff. We're looking to make a change from HTTP to HTTPS. So it's a, you know, a fairly simple change, like, you know, and I ended up, for this one, I ended up writing a pretty, you know, complex regular expression to do this. But once I had the regular expression working, I'm like, okay, like now let's see if I can write a bot to do pull request generation. And so the GitHub Security Lab has a bug slayer program. And I figured, okay, they had a program where if you fix, so the first one was write a query, submit a query, and we'll pay you money for it, right? They have a, that was the all for one for all. On top of that, you can use that same program and submit to maintainers, hey, you have this vulnerability, and get a CV sign. And if you use a CodeQL query to find those vulnerabilities, they'll pay you $2,500 maximum for 4 vulnerabilities. I figured there were 17,000 repositories with this vulnerability. So if you do a little bit of math, it's like, you know, $1 million worth of like bug bounty payout potentially, which is not actually, didn't actually happen. But, you know, I figured math, right? So how did I build this thing? I used the Hub CLI, Python, PyGithub, and PyGithub. I used async.io to do like a lot of things synchronously. In Python, and then one very annoying regular expression, and a lot of bouncing off the rate limiting API for GitHub. And yeah, generated thousands of pull requests to fix this one. I think I generated 1,596 pull requests for this particular project. And GitHub paid me they said this is worth $2,000, but because of the number of vulnerabilities you found here, the number of cases you fixed, they doubled the amount up to $4,000 just for the number of cases that I fixed with this pull request generator. Okay, so the second case was a code generator, a vulnerability in a project called JHipster, which is a code generator that generates your base like Spring MVC application and all like the nuts and bolts of like getting you just like this base application up. And I found this vulnerability. This was the use. So the vulnerability was the use of insecure random number generation in a security sensitive context. So how did I find this? I was looking into a while ago the use of random string utils, which is an Apache Commons Lang 3 library, to generate random strings in a security sensitive context, right? So like in passwords, in activation keys, in reset keys, right? So the reset key is in this case, right? Like when you do password reset, right? I need to reset my account. You say, hey, give me a token, and that token, right, that you get from the server needs to be randomly generated. If it's not securely randomly generated, when that ends up in your email, you can say, I can then, if you get like 1 or 2 of those numbers, you can then compute what the next number will be for one of those password resets. And so when, you know, you can then send a bunch of password reset emails to a bunch of other people and know what those tokens will be, and then you can do the reset on their behalf without ever seeing their email. And so random string utils from Apache Commons Lang 3 uses an insecure random number generator under the hood. And I found this code, and I'm like, you know, I kept finding the same code everywhere, and I'm like, what is going on here? I eventually found out it was coming from a code generator. Right. So this is the sensitive one, right? Generate reset key. This is the reset key for resetting somebody's account. And when you search for this class, right, utility class for generating random strings, which is indicative of this this JHipster code, it came back with 14,000 results. Unfortunately, GitHub search limitations. There's no way. It only returns the first 1,000 results, even with pagination, and there's no known way to slice the data with additional search parameters to get you more information. So special thanks to Chris Gavin and Arthur Bars. I actually just talked to GitHub and I said, hey, I have this limitation. Can you get me a bigger list? Apparently there's some hard-coded limit of 1,000 results, and they actually like changed the code of GitHub and like were able to run a query and like gave me this data. And so that gave me 9,000 repositories, a list of 9,000 repositories. And I imported these 9,000 repositories into lgtm.com to then run my query against and find all the vulnerable instances. So how will we rewrite the code? So this is where we enter with Jonathan. So I was looking for a solution. One of the things that I've been playing with is, okay, like the first time I did this, I used a regular expression, but we're actually changing code this time, right? This is actual, like, you know, and even though it was generated by a code generator, it may have different formatting, and if it's different formatting, it's going to have a much more difficult time getting accepted by the maintainers. So how do I, and also, like, I don't want to write a regular expression for this thing. So how do I do this in like a sane way? And thankfully, I've spoken to Jonathan. He worked at Gradle before. We had a lot of conversation about this, and I'm like, how do we do this together in a constructive way? So I'll let you take it away for a demo of rewrite. Before we bring it back to me, but yeah, let me unshare my screen and you can take over, John.
Sure. Yeah. Thanks. Let's see. Just as a little bit of background, rewrite. I posted the link to this GitHub repository earlier, but it was a technology that originated at Netflix. I worked there on a central engineering tools team. There were about 700 engineers and 2 of us trying to get 700 engineers to do something. The big cultural imperative there was freedom and responsibility, which meant product engineers could do whatever they wanted. As a central team, you could not put any gate in place, couldn't break their builds, couldn't anything like that, right? So if they wanted to use something different, it was up to them. That means that there's 700 engineers, there's 1,100 different styles, and it's just like it's all over the place. So we worked on building a lot of reporting tools originally, trying to surface issues to help them understand where they needed to make changes. But we're engineers, and unless it's gonna like break, we're not gonna do anything. So they had an internal logging library that had been that was basically like SLF4J, a common Java logging library. They wanted everybody to use SLF4J, deprecated the internal one. 6 years later, there's still 5 million references to this thing. So it's just one of these kind of things, like it's never going to go anywhere. You're never ever going to be able to root it out. So that's where the sort of genesis of this automated refactoring technology that also did a lot of work to preserve style. Rewrite is an abstract syntax tree based manipulation. But unlike most abstract syntax trees, the actual formatting of the code and type attribution is maintained inside of that AST. And it's also made to be acyclic, which most ASTs are not, to make it something that you can actually serialize out and operate in mass offline. So today we're able to operate on millions of source files, in a horizontally scalable way, performing different sorts of transformations. Like Jonathan says, I have a sort of brief video here that shows some of these technologies. And what I'm going to show is actually a view of running rewrite recipes from nascent SaaS that my company creates. But all the rewrite recipes themselves are open source, Apache license, can be applied through build plugins and other sorts of workflows as well.
Cool.
Just gives it an easy way to demonstrate it. So with no further ado, we can start somewhere simple, like just trying to find types, find where particular types are being used. Jonathan was looking for uses of random string utils earlier.
Can you full screen it?
Yeah, sure. What if you wanted to find an actual
That actually it dropped when you full screened it.
Yeah, let me see. I don't know. What's the right? No.
Thank you, technology.
Yeah.
Yeah, I think this is about what we're going to be able to do here.
Fair enough.
Yeah, this is theater mode, so it's kind of like full screen or
You're not.
Yeah, right now there's no screen
Did
at
it
all.
drop the share?
Yeah.
Drop
Okay.
share entirely.
We're gonna go with the theater mode, and I think that's the best we're gonna be able to do.
Yeah.
Okay.
So
can you share your screen again?
Back?
Okay, awesome. Cool. Peachy.
Yeah.
Yep.
So what if I wanted to find a particular method pattern? Say like in this case, I was looking for a particular occurrence of that random string utils. Because the abstract syntax tree that we're operating on is type attributed, we're able to actually accurately identify the calls, like in this case, like make ders. But we know that this receiver type is of type java.io.file. And that's essential to not get a, sort of over-reporting situation, into an over-reporting situation where we're, eagerly matching on just the name and not the type. So we actually, in addition to code, we have abstract syntax trees for things like Maven, actually. So, we have an abstract syntax tree for XML, for YAML, for properties, but we can layer on top of those additional models of what that XML means or what that YAML means. In this case, here's an example of actually looking for the JUnit, which is a unit testing library in the Java ecosystem, on the compile class path. So in other words, this testing library is going to be shipped with main code and ran in production, which is, I think, not intended. I think there's commonly vulnerabilities in unit testing libraries that, that would make them sort of like an undesirable thing to have on your runtime class path. And here you see, Neo4j, which is a common graph database in the Java ecosystem, leaks the JUnit onto the runtime class path of any of its users. And so it's kind of, whoops, right? Test dependencies don't belong in the app. So what if we were to actually go and say exclude it? So we're going to take the same group and artifact, and we're going to say, I don't ever want to see this in the compile scope again. I can go and I can see that it, adds this exclusion block to the POM. Part of being style preserving means that it detects that this file actually used tab indentation, and so it indents it over to the right in the way that a human would if a human were inserting this. And we take all these little building blocks, right, like find methods and change methods and find types and all these different things, and we can build them into higher and higher order things. So in this case, we're doing like a whole testing framework migration. And you see where, the combined effect of this is, we're changing imports, automatically in a sort of like in a way that respects the import style of the original project. I'm trying to get back here. Able to strip modifiers off, change annotations, insert lambda expressions, all sorts of types of different things. And that's kind of where we're at. So yeah, head on over to Rewrite. We'd love to see your feedback on that. And the sort of what we'd like to see for security researchers, I think, is a world where you don't just disclose a vulnerability and make it known, but you also are in a place where you develop the remediation that helps fix the issue. And so that's a sort of like ecosystem that we're trying to build, one where you provide help to those engineers that are affected by the vulnerability, as opposed to just adding to a work pile, which is kind of ever increasing.
Absolutely, because while it's very easy to point at a problem, giving them a solution is much more palatable.
It is, yeah. So I'll turn it back over to you, Jonathan. Thanks for your time there.
So this is can you see my screen again?
Yep. It's coming up.
So this is the diff of the change that Rewrite did as an example. So you can see it's adding a new import, adding new code in the right place, changing the generating this new method, and then changing all the calls to that old vulnerable method to use this new method. And again, syntax preserving, all that stuff. And the result of this was for the JVM, so results of my pull request generation. I haven't checked the newest numbers. These were from when was Nova? 2020. It was like November or December of 2020. So for the JVM ecosystem use of HTTP, I generated 1,596 pull requests. As of November, there had been 422 merged and 147 closed. A lot of those closed ones are were closed because they were merged, but like the maintainer merged themselves and then closed them. And then for the JHipster one, it had been relatively recent. So even it had, the first one I did it and it had been, 11 months. The second one I did it in September, and then I was presenting this in November. And so there were 3,880 pull requests and 56 merged. So it hadn't been very long. Also, a lot of the JHipster ones were like one-off projects. I did get a couple of I was basically going for like wide, because I knew there were going to be some legitimate projects in the noise, but it was really hard to identify the legitimate projects. A lot of the JHipster ones were one-off projects though. Like the people just generated it, tested out JHipster and stuff like that. But I did, get some of those like, projects that were actually using it and that actually cared. So there's some lessons learned from bulk pull request generation. Lesson learned number 1, sign off on all generated commits. This will significantly increase the likelihood that PRs will be accepted because most people have a CLA requirement, and this you can also just sign off, and that that solves a lot of those issues. Have fun with it, live stream it, which is what I did. Yes. So I live stream when I do bulk pull request generation. I live stream it. I invite people to come in. I have fun with it. Like things break live. My computer overheats. Just create some sort of save state because my bot failed, and so knowing where it failed and then being able to pick up and not regenerate pull requests that had already been generated, that's a really good thing to have. Yep. There exists a max writes per second API limit on GitHub that's like very hard to find. Quote, if you're making a large number of post, patch, put, or delete requests for a single user or client ID, wait at least 1 second between each request. This is the biggest rate limiter that I have for generating pull requests. So yeah, I have run headlong into this, and it's annoying, but what GitHub's got to prevent spam. So yeah. One of the things that I learned that I did not know, kernel task on Mac exists as a software hack to the CPU overheating problem. If kernel task is using 500% of your CPU to prevent it from catching fire. Yes, I actually learned this. Running OBS and my bulk pull request generation at the same time makes a hot CPU. Don't fork 1,500 projects against your personal account. That was my account. They fixed that. Yeah, so but like my account, if you went to github.com/jleitschuh, most of the time I would get the angry unicorn of this page is taking too long to load. They have fixed a lot of these things, and my page now loads much quicker, and I don't get the angry unicorn most of the time. But I learned not to fork things against my personal account because of this.
Just most of the time, huh?
Yeah.
What's the recommended alternative, by the way?
I will get there.
Okay.
Live streaming and running this bot on the same machine will cause CPU overheating. Yep, I actually used an ice pack underneath my machine in order to keep my CPU cool. Forking thousands of repos with Hub will cause name collisions. This is to answer your question. So because you're forking thousands of repos, if Hub doesn't if you hit the fork button in GitHub, it'll automatically rename it if you have name collisions. When you use the Hub CLI command, it doesn't rename collisions. So how do you solve that problem? Solution, rename the repository after creation. That adds another write. This requires a second write operation for every repository. So I didn't do that. What I did do was create 35 bulk security generation projects or organizations against GitHub. So I have 35 organizations, and I failed over subsequently to each organization to generate the fork against. And so, yes, this is the number of organizations that I have assigned to my account. I have 35 organizations that were just the subsequent failover of this won't fork because there's a name collision. All right, try the next organization in line. And so, yeah. Yep, that answers your question. It's terrible, but it works. One of the things that I learned is do not click enable all on dependabot alerts or dependabot security updates after you've done this to your account, because you will end up with a boatload of spam against your notification feed. Yeah, my notification feed died. Don't do anything of this with your personal account. Yeah, I will do it again with my personal account. I don't advise it, but like yeah. So that's my slide deck on bulk.
What is the alternative to your personal account? You said you're
create
going
a
back
bot account. Like create some other account. Do it from an independent. I will probably do this again against my personal account because I like the identification of like this was me, and also like I get the notification and stuff like that. But like so GitHub has also, so here let me there's been yeah, so this project's been actually run more than just those 2 times. GitHub actually used my bot to fix CVE 2020, this one right here, that was found an array overflow in it was an R hostname overflow that had a cert advisory, and so they generated 1,885 pull requests using a GitHub bot account using my pull request generator. That code's not in this repo, but they have utilized my bot in the past to also fix security vulnerabilities like this as well. So GitHub's also, I mean, I don't know how often they're going to use it, but they have been taking advantage of this technology as well. So and each project that I have that I do this thing, I just throw another file in there, and it's the fix is specific, but the engine underneath it is generic to like, how do you generate pull requests, and like, here, add a method for the hook for, all right, this repo exists, what change do you need to make to it? So yeah. Yep. So that is me. Any questions?
So
Yeah.
how much?
Okay, go ahead, Brian.
I was going to say, so how much work went into each, generating the file that the engine uses each time? Because I mean, I'm wondering, okay, here's a brand new CVE that comes out tomorrow, for example, against something critical in OpenSSL. How would you go about addressing that?
So the actual work to add another so what I use for rules are I've used lgtm.com, and they have a JSON output which they hand me. I write the query. I say, hey, can you give me all these results? And they'll hand me this massive JSON file with, here are all of the repositories and the files that we found this vulnerability in, right? So that gives me the repo name and the file, right? The file impacted, and potentially even a line. But I didn't deal with individual lines. I just said, okay, this file is vulnerable. Let's fix wherever it is in the file, because I might be forking it in the future, slightly past when the CodeQL query was run against the repository, and the repository might have changed. So the first step is just identifying the files. Now that I have the files from all of that, my engine takes all those files, and then you have a generic method, which is, here's this file that exists, change it. And so for, I guess it's from there. Jonathan, how long did it take you to write the rewrite rule for that JHipster thing?
It was quick for us, and I mean, it's gotten even easier since then. So, I mean, I don't know, 20, 30 minutes, I'd say.
Yeah. And then he threw awesome part of it was that, like, I didn't run it inside of this engine. He just said, here's he's a GCP endpoint. Post the file to this endpoint, or post the contents of this file to this endpoint, and it'll respond with changed file. So I just shot it up to GCP, and then he gave it back to me in a fixed state, and I just wrote it to the file system. So I didn't,
Yeah, we kind of broke Google Cloud Functions too, basically. I mean, not like broke, but definitely saw the limitation of that too.
Yeah. It's like, oh, I need 50 of these instances, because clearly the load is through the roof, and then it would crash and not crash. But
the main problem there is that there's no disk.
Yeah.
On serverless, so that you just if the repo happens to fit in memory, you're okay, and if it doesn't, you're not okay.
Yeah. Yep.
Yeah. So I think we did it on a per file basis, which was pretty wild, but
yeah.
With the rewrite efforts on that particular bug, did you end up breaking anybody?
I don't think
the change that
so.
was being generated. Yeah.
No. I don't think that, again, it's not, I'm not committing, so you kind of have to approve it as a pull request, right? It's, I'm not, but I think that everything compiled. I didn't see anybody complaining about, oh, this doesn't compile.
Okay.
Yeah, but that actually was more or less my question. There's that phrase, to err is human, to automate errors requires a computer. How do you test this so that before you start generating 1 million pull requests, you have a fairly good confidence that the whole thing is actually generating? I understand in special cases it might not work. That's true for humans, but I'd like most of those pull requests to be correct. How could you gain confidence in that?
I tested against 1 or 2 repos, and then I just I let it rip. I spot check, But yeah, so I run the body of the pull request, the message by Xavier at GitHub, to make sure that I'm not going to get flagged for like abuse, right? So I've got a lot of context inside of GitHub to make sure that like, hey, I'm gonna do this, right? Like, don't shoot me down because like I'm doing this in good faith, right? And so they know ahead of time. Their abuse team knows ahead of time that I'm doing this. And I don't know, how did you test the change actually? Like, I mean, it was a very stamped.
I'll show you actually. It's just easier to see. Like there's a pretty elaborate testing harness for the actual rewrite recipes themselves. So here's like a unit test actually that demonstrates a test for change method name. And you get to specify the recipe, the before text. This is what's kind of wild. Even in the IDE, its syntax highlights the little unit test that you have running here. And then you can verify after text here, and you can dump libraries onto this. And so it's actually pretty easy to build up a little testing suite that just looks like before after code.
Okay. So you had a bunch of unit tests in along with the transformation itself.
Yeah. This transformation was fairly straightforward, I think. The more complicated ones, like when we do JUnit 4 to 5 or assert, like JUnit assertion is assert J or something like that, we'll just unit test it out just like you would any other main code.
Daniel, you have a question?
Yeah, I was just going to say that you could use the presence of continuous integration configuration in the repositories to go, 2% sample of the repositories that have got CI, submit the PRs, and then watch the check data that comes back.
Ooh, I like that.
Unfortunately, so I just had a conversation with the GitHub team about this. They just put a check in for GitHub Actions that means that if you're the first time contributing to a GitHub action or to a repository that uses GitHub Actions, a maintainer has to explicitly sign off on the first change because they've been dealing with so many issues around crypto miners. So they've implemented this new not auto running for first time contributors.
Yep.
But nevertheless, it still would be, the odds go up if there's a problem. One of those repos is more likely to detect that before you send it to, say, the other 98%.
Yeah,
it wouldn't be a real-time thing to do. It would be a case of like, okay, I think I've got something that I want to do this for, submit to a small percentage, wait, perhaps several days for enough people to have clicked that button that you can be confident that things are generally passing and that no one has said, hey, this change is crazy, back to you, and then go wide.
I had one, so the big push, one of the biggest pushbacks that I got against the HTTP downloaded dependencies Maven one that I got was I was not checking to see if the server that I was changing the URL to actually supported HTTPS. And people were, that was one of the biggest things that I got pushback on. And my response to most of them were, I just fixed the code, right, that has a vulnerability, but you need to go and contact the maintainers of that server because the server clearly is not, the server not supporting HTTPS is your vulnerability. So talk to your consider this the impetus to go talk to the maintainer of whatever dependency server you're using to say this, you need to be supporting HTTPS.
And you could have included that in the pull request itself, where oh look, it doesn't work, and hey, you're also going to need to fix your server.
I also support. So I say that I support this in my. I have a very long description of the pull request, and I say if you want to opt out of bulk pull request generation like this, drop a .github.gh-robots.txt file into your repository, and I won't generate. And so I don't have support for robots.txt in my repository. I just check to see if any repositories on GitHub have that file yet before I run the bulk pull request generation. And I have yet to see anybody drop that file in any of their repositories. So
I'm going to go drop it in mine right now.
Yeah, go for it. Yeah, you're right. Yeah.
One thing that hasn't been said about bulk PR generation here, which is interesting, I think, is that unlike when you do this sort of manually, when you do an effort like this manually and open PRs, it could be an exhaustive amount of work to go actually open it all up, open all those PRs. And then you think, how many people are going to actually action these things in a reasonable period of time? When you do bulk PR generation, you can basically just force push over the branch repeatedly. So, you can basically keep the PR current over time, as it moves forward. And even in some cases, detect when the diff becomes null and just close the PR.
Yeah.
So there is an advantage to bulk PR generation that doesn't exist when you do things manually, I think. you
So I
sort of
can
have to
see-
time things, and yeah.
I can see this actually being used by some organizations or projects just for doing non-security fixes as well. I'm thinking, in Zap, we updated Log4j. We've got 35 repos. It's a pain. Being able to
It's terrible,
generate a
isn't
whole
it?
load of upgrades like this
Yeah.
would be brilliant.
Yeah, I mean, we just talked to somebody this morning. They said that they had estimated 1,497 days of engineering time to move from JUnit 4 to 5, and now it's 5 days. And that's like that's kind of the thesis, right? Is that like maintainability is destiny in code. It used to be optional. I think when I go back to like working for an insurance company 20 years ago, we had like a lot of on-prem software that like ran on WebSphere and could still very legitimately be running today. But now when you develop software, it's all integrated with third-party libraries, with APIs and so forth. And if you don't keep it current, it just ceases to function. So at this point in 2021, code at rest ceases to function. And yeah, it's, so now you're on the hook for that maintenance, whether you want to or not.
Yeah. One of the things that I think I would like to do next with this is I would love to integrate. I'm working on some automated disclosure infrastructure, and so the vulnerabilities that I was looking at mostly were like, I realized the JHipster one was like one-off projects, a lot of those, but I'm looking at some more vulnerabilities that are kind of more widespread in like components that are not tests, right, but like are actually in core components of like the Java like code flow, and I'd like to automate the process around like. I sent you this pull request, you merge it, and then I respond, thank you for merging. This will automatically have a CVE number assigned to it, unless you say stop. Like unless you comment like in all caps stop. And so that would allow like the automated disclosure of these kinds of vulnerabilities that have been automatically fixed to also have an automatic CVE issuance process coupled on top of that. That's a bunch of infrastructure that I have not thought about how I would build, because you need to do monitoring, and this is currently run as a one-off event. But it's one of those thoughts that I've been kicking around my head is like, how do I find this vulnerability, fix it, and then also like deal with like the potential 1,000 CVEs that need to get generated from that vulnerability. So yeah.
There are dangers there as well, because there's a pattern someone can search for, then the bad guys can search for it as well. And if you're talking about software that people have got deployed somewhere, then they're not going to actually update everything immediately. And let's go, okay, let's look to see what these guys are doing. Oh, they fix these things. How can we abuse them before they get, all the fixes roll out?
So one of the things that I'm thinking about in that area is this is like it's really awkward because again, security researcher, but you're finding vulnerabilities at this kind of scale. One of the things that I am leaning towards potentially doing in the future is tying this into GitHub sponsors. So if you sponsor me on GitHub sponsors, I'm more than willing to privately disclose things to you like ahead of time. I will also potentially disclose things privately to like the Apache Foundation and stuff like that. But in general, writ large, like if unless somebody's sponsored me specifically to do private disclosure, right, I will just do the bulk pull request generation because I just don't have the time, right? There's not enough time in a day, and like. Yeah, but like I'm willing to do it if there's financial money in that interaction. So yeah.
Hey, Jonathan. So a lot of this is tied to LGTM and CodeQL, which are came from SEML, which is now has been bought by GitHub.
Mm-hmm.
Do you see any changes coming to that technology that from the GitHub acquisition that might help or hinder what you've done?
I'm concerned about the direction of GitHub's integration of CodeQL. I'm sorry, Gray, because Gray is a manager at GitHub, so he's hearing me say this. I'm concerned about the direction of CodeQL being like conglomerated into GitHub, because currently the best way for me to do my open source security research is so in lgtm.com. You can import each project that you want to run queries against one by one. And in order to import the thousands of projects that I do to find vulnerabilities at scale, I have written a bunch of scripts that use the API for the user interface, which is all an internal API, to bulk import like the entire Apache organization into my account so that I can run queries against it, right? GitHub, who works at GitHub, that like people at GitHub can run their queries against all projects, but like for us, we kind of have to hack it together. And I'm seeing that LGTM.com is not the direction that this CodeQL thing is going in terms of the future of the product. And I see the stuff like the code scanning results that GitHub offers per repository, where things are headed. But that information and those CodeQL queries and that all that stuff is specific to the repository and is not in a place, because what LGTM does is they compile the code, they save the database, and then they have a version of that database that they store on their servers, and then you can run your query against thousands of them. The direction that's moving towards GitHub, I've not yet seen a story that replaces that workflow for security researchers for doing security research as things migrate from LGTM, which seems to be less and less of a priority for future fixes and security improvements, and everything's moving towards moving to GitHub.com. So that's concerning, but I have been assured by a lot of people that it's a priority, but there's no stories that have been communicated around how that's going to play out.
Cool.
I can talk that a bit if you want.
Cool.
It's basically GitHub bought SAML in 2019, and what we bought was mainly a variant analysis tool, which is what Jonathan was talking about when he talks about kind of hacking together a query himself. You do that when you're like looking for variants for a particular vulnerability. It wasn't really a static analysis or like a classic SAST tool. It wasn't something that people ran in their CI. Folks did a little bit, but not so much. The first thing that GitHub did with it is take it and say like, okay, well, we want to take the goodness of this and have it as something that works out of the box as a more like standard static analysis tool. So a lot of investment went into the code scanning side, which is running on every commit, every pull request, surfacing results there. Not as much went into integrating the functionality around variant analysis into GitHub. But that's kind of just a phasing thing. We're not reaching the end of the static analysis part, but like we've done the big heavy lifting on getting a static analysis integration into GitHub. And we built out the flow for other static analysis tools to submit to code scanning as well. The next big thing on that team's list is building out the query console from LGTM and building that into GitHub and using the databases that open source either generates because it's running static analysis anyway, or because they've been pre-run by GitHub, making those available in a query console. We're putting together those plans now. It's not entirely clear how it's going to run. We know it's going to run on the actions infrastructure under the hood to do the scans. It's not certain yet whether or not we'll use code spaces and have it as like a basically online VS Code experience, or we'll build a dedicated UI for it. But it is coming. It's just not been the priority over the like first 18 months of like SAML at GitHub.
Great. What, GitHub doesn't have infinite resources to get this done now?
Who would have thought it, eh?
I totally understand. Thanks for speaking up about it. Cool. So this has been very interesting. Thank you, Jonathan and Jonathan. I really appreciate it. Jonathan Schneider, if you feel up to it, please feel free to come and join these meetings in the future. We're trying to figure out the best ways of helping everybody, and Rewrite sounds like an interesting tool. So
yeah. Thank you, Gray, thank you, Gray, and everybody at GitHub who's like made this work possible to begin with. Like, I'm just taking advantage of a bunch of APIs and like pulling a bunch of things together, but like, all this infrastructure, I'm standing on the shoulder of giants. So like,
well, we're just trying to help other people do cool shit, right? That's our job. So, pleasure.
Yeah, and thank you, Jonathan, for hey, I have this project. Can we do this together? And you're like, yeah, like totally. So yeah, like it's awesome. Thank you so much for just like jumping on there and going for it.
Yep. Mm-hmm. Always.
Excellent. So do folks have any opens or anything else in the last few minutes? Or is everybody
First of all, I am intrigued by this. I think it would be wise for us to think about what is important enough and widespread enough to approach this way.
Yep.
I proposed in the notes a thing about Aura. We just don't. I think we're run out of time. So I would propose picking that up next time so that they have a chance to talk, as opposed to just, hey, you got 60 seconds, say everything.
Yep, definitely makes sense.
Are there any particular tasks? I mean, you don't have to know right now, but what other things might be widespread enough and worth fixing this way? Jonathan, you may already have some things in the queue or thinking about some things. Jonathan L.
I have a thing. I tend to focus primarily on Java stuff. I can do C++ if somebody writes the rule for doing the C modifications. Jonathan, how's your stuff handle C and C++ currently? Because I know that there's a lot of stuff there.
We don't.
Yeah,
You really have to build each language. Yeah.
Everybody, a lot of C languages vendor their stuff. So that's where a lot of vulnerabilities tend to like, you know, propagate a lot more than the Java ecosystem. So if somebody has, you know, basically if somebody writes the rule and like has either like a code that I run, some code that I run, or like an endpoint that I can hit with code, like as soon as that exists, I can run and like a list of projects that are impacted. With those two components, I can, you know, run this and do another live stream and have a blast with it, right? Like, you know, I'm using, yeah.
Although, you know what, if it's straight up vendored, you may not need the sophistication of rewrite. I mean, seriously, here's the line. A diff works. We're done. You may not need the sophistication to fix. You copy that code 10 years ago, and things have changed since then.
Sure. Yeah. One of the biggest, I think. I mean, this is at a different scale, I guess, but I mean, I'm thinking about things like if you've heard of Spring Boot. Like that project, the 1.x line was alive for 7 years, and then you know they've released 2x. 2x line's going to live for 2.5, 3 years, and then it's going to be 2 years, and then it's going to be 1.5 years, and like that's a pretty tough migration, So a lot of people say, oh, it'll take us 2 months, 3 months, Well, you can't do that every year, and if you fail to do it, then the next time there's a CVE disclosed on Spring Boot 1x, have fun. You're on your own, right? And those are the things I think that are you gotta move forward, right? It's not optional anymore.
Yeah, although I do think that it's a two-way street. I mean, if you're changing the APIs that much as a library, at a certain point I have to say, shame on you. Stop writing code.
It's true.
You don't belong in the industry.
It's true.
You're just creating a vulnerability, and you're going to do that.
Well, kind of. I also think that there's a valid. I mean, if it's enough of a problem, right? Like there needs to be financial incentives to say, this is you can't be doing this, right? Like, the reason that COBOL, like people keep updating COBOL is like because like there is so much financial incentive behind don't break anything, but we want to run the latest version of COBOL, right? Like that's the financial incentives that exist, right? There are fewer financial incentives to don't break APIs because like they're being driven crazy by like old decisions that are holding them back, right?
Mm-hmm. Yeah. I think you look to an organization, and I don't necessarily admire this, but you look to like a Google, say, and they do the monorepo thing. And why do they do the monorepo thing? They do the monorepo thing so that they can move, they can move forward. When you make a change, it propagates across the code base. That has consequences to the organization's culture. It leads to heavy code review culture, which does slow things down a little bit, but it comes with the significant benefit of, keeping things moving forward. I tend to look at the world as like one big, repository of source code. And I think my view of like being able to automate source code transformation is that, it's like an eventually consistent monorepo. It's eventually consistent with in the sense that people, merge basically to fix. And the world I want to see is basically one worldwide, eventually consistent monorepo. That would unshackle us from like, whoops, I made this API decision 5 years ago, but I'm now faced with this sort of like impossible decision whether to maintain it for another 3 years or hurt my user base or it'd be nice if we could innovate without that cost.
Right. I think you make a fair point. I think the problem is right now today, the word eventual has an incredibly long latency.
Yes.
It's long tail, right? It's long
Yes.
tail. Yeah,
Right.
it is. It absolutely is.
So I guess I kind of agree with you. Things we can do to make things easier. And I do think there are sometimes ways you can make things easier in other ways.
Yeah,
that
for sure.
Don't necessitate that, but
Yeah.
if we can make it easier to move forward, then great.
Yeah.
Okay, well, we are out of time. Thank you, everybody. It was a great discussion today. Really appreciate it.
Thank you all.
Thank you.
Thanks,
Yes.
really good.
Yeah, thank you.